Hey TechKnowStuds! In this module, we're going to start taking a look at the history of computers. Where did we start and what did we build off of? And how did it transition to where we're at now? Because it's been a whole process. And we're going to dial things back to 2400 BCE, where the abacus was created. So this is what the abacus looks like, and it was something that was used to process data. The input would just be my finger, where I would go through and adjust these beads as I calculate and do some calculations to figure out some sort of mathematical problem. And then this one actually has a little reset, so I can press it and it will actually reset those beads. But this is contributed as being one of the earlier processing, earlier calculators. So whether you want to call it a computer, it's certainly not a modern computer, but it actually does calculation and helps us do calculation. Next up, we have the Babbage machine in 1820. And this is the idea that there's actually a mechanical process that does calculation. And here we are at Wikipedia, where we see the difference machine, which was created by Charles Babbage. And so here it's a mechanical machine. So it's an actual process with spinning wheels and gears. And in fact, I think there's a video on here. So we scroll down here, here's a video. And so as you can see, it actually does this processing where it spins these gears and stuff to do the calculation. Our next stop here is 1934, where we started creating vacuum tubes to create computers. Here's a vacuum tube, and this is actually relatively small compared to the way vacuum tubes used to be, and there are larger ones now today too. There are still uses for vacuum tubes. In fact, if you, a guitarist who has an amp, a lot of times they like the old vacuum tube guitar amps. So what this does is this is like a mini switch. This, or not so many, this is a switch. And they would line lots of these up to create calculations so they could do the calculations. And it uses heat, so they would actually have to warm this up. It would warm up to make this thing work. You'd use a lot of electricity and generate a lot of heat. And then in 1947, we started using transistors. So here's that vacuum tube that we looked at, and here's a transistor. And there's a couple real key differences with this. Number one is just the size. This is quite a bit smaller, and remember the vacuum tubes were quite a bit bigger. And then number two, this used heat in order to work, versus the transistor does still create heat. This still generates heat, but it's not something that you generate heat to make it work. It just generates heat because it is working. But essentially what we have here is a switch. It has something coming in and out, and that creates a complete circuit between those ins and outs if we apply voltage to the center one. We were able to figure out how to get that into a smaller size, into an integrated circuit. That's when we started creating not just a single transistor in this brick right here, but started including many transistors in one of these little chips. So here we can see that transistor, and now here is a little tiny chip that we have, a little integrated circuit. And some of the differences that we see here, number one, this is smaller, yet has more transistors in it. We see here that this has 3 inputs into it, or 3 prongs on it. This actually has 8, so we're capable of doing more with this. And I don't know specifically what this chip actually does, but I've worked with these chips that have maybe just a few of these on there, and I've worked with these chips that have a lot of these, thousands of these on it. So an integrated circuit has a lot of these different transistors built into this chip. Now, integrated circuits are usually designed and created for some sort of specific function. They're designed to take some sort of input and give some sort of output. It does some sort of processing with this little tiny chip, but it's very specialized with what it does. Then in 1971, we start creating microprocessors. So here's that little integrated circuit that we had right there, and it has 8 prongs on it versus a microprocessor. Now this is a microprocessor. One thing we notice, it's much bigger, but the reason is because this one might have, tens of transistors in there, 10, 20, 30, maybe possibly even hundreds, maybe not. This right here, this CPU probably has millions of transistors in it, and there's even some processors with billions of transistors. And we can see here, this has 8 prongs as the input, and this has hundreds of prongs on the back here for input into this processor right here. And to see how we have progressed, in 1975, they came out with the MOS 6502, which actually was used in the Nintendo Entertainment System when it came out. And it has over 3,500 transistors in it. But then in 1978, that's when the Intel 8086 came out with 29,000 transistors. 95, we got the Pentium come out with 5.5 million. In the PlayStation in 2000 has 13.5 million. The Xbox in 2005, the Xbox 360 has 232 million. And the Apple M2 Ultra, which is actually a lot of transistors even compared to today's standard, is 134 billion transistors in it. And what we have here is this is how they produce these integrated circuits. What they do is there's this process that they go through for etching material on these discs, or they're called wafers, and then they'll cut out the processor. Each one of these right here is a processor. So you can see that this wafer right here has lots of processors to it. Now here's just an example of one of the size of the wafers, so you can see, and it's got that kind of interesting rainbow effect on it. But this is not fully developed yet, but this is how you can kind of see how big that wafer looks like. So one thing to get out of this is that these microprocessors are extremely complex. And I don't know that you can find somebody that could describe every single little detail of how this microprocessor works. Instead, you've got people who've developed it over time, and even now you've got teams of people working on a small component, a small section. Because what happens is that these chips are actually broken off into these different sections. And if you look at a chip up close, you can see patterns, certain patterns in different areas of the chips, because different parts of the chip will do different functions. So it's pretty fascinating how this stuff has been developed and where we're at now, and pretty amazing on the power that we get out of these microprocessors.